All right, so far, you guys, all we've done really with the normal distribution is the empirical rule, which is the 68, 95, 99.7 rule, right? So the normal distribution, you guys, is when we standardize everything, and so we make the mean 0. So this n means it's normally distributed with a mean of 0 and a standard deviation of 1. All right, mean of 0, standard deviation 1. So when you draw your picture of the normal curve, we've got the mean is 0. We've got 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, and -1, -2, -3. So we can standardize any data and convert it to the normal curve. So again, just a reminder that 68% of the data falls between 1 standard deviation, top to bottom, and 2 all the way across is 95% of the data, and 3 all the way across is 97, or what was it, you guys? 99.7. Okay. All right, now we also learned how to find a z-score. So this formula right here tells us how to find a z-score. So I'm going to write that down again. So this is your data point, okay, whatever the data point is that you're looking at. And this is the mean of the data, and this is the standard deviation of the data. So when we did the alphabet backwards, when we ran outside, broke our shoes, that's when we converted to z-scores, and you could tell whether you were like way better than someone else in class or way worse than someone else in class, right? It's hard to know if 30 seconds is a good score or bad score unless we standardize it or compare it to the mean. Okay, so what if we want to find the percent of observations less than a z-score of 1.25? So instead of 1, we know how to do it if it's 1 because we have the 68 rule, right? But what if we want to do it when it's 1.25? A little bit above 1 standard deviation above the mean, right? So we're going to use what's called table A. So you guys do this. We're going to draw a picture, right? So we draw our normal curve, and we always should draw a picture to help us. And when we do our normal curve, our mean is always 0, and our standard deviation goes by 1. Okay. So I want to find the percent of observations less than 1.25. 1.25 is our z-score. So we come over here past 1, and I want less than that. Less than 1.25. If it was less than 1, we could find it using the 68%. All right? But 1.25, we're going to use a table that's in the back of the book. So the table, you guys, that's in the back of the book always finds the area under the curve that is to the left of z. That's exactly what we're looking for, to the left of z in this problem. And so we're going to go to table A. So you guys do need to find table A in your book. It's in the very back, and you might want to mark it with like a sticky note or a piece of paper because you're going to be flipping to it a lot. So again, it's really important that you know table A tells you the area under the curve left of the z-score, all right? Always left of the z-score. So everybody's going to find 1.25 positive. So you guys are probably on the negative page. So you need to flip it over one page. That's positive z-scores. And you should go down to 1 over here on the left and 0.5 over here. Hard to read, but try to find it in your book. So, oh wait, why did I do 1.5? Yeah, I want 1.25. So we go to 1.2 and then 5. 1.25. All right, so we got 0.8944. Okay, 0.8944. So for the area that's left of the z-score, we do round a lot of the times. 89% of the observations are below a z-score of 1.25. All right, so if you have a z-score of 1.25, say on a test, you did pretty well, right? You're better than 89% of the class. Okay, what if I want to find out how much area under the curve is greater than negative 1.78? So again, let's draw our normal distribution. And I would like pictures on these, okay? I know it's kind of annoying after a while, but you got to get used to drawing it and visualizing it. So we've got 1, 2, 3 standard deviations above, -1, -2, -3. So this one's kind of close to -3, and we're going greater than. Now, this is important. This is a common error on the AP exam. So greater than, you guys, what does this table actually tell us? Less than. This table always tells us less than. So if I go to -1.78 and find the area under the curve, let's go ahead and do that. So flip back a page to the negatives, and let's go to -1.7, and then you got to arrow over to find the 8. -1.78. Did I do that right? Yeah, 0.0375, okay? 0.0375. What is this actually telling us? This is telling us the area left of -1.78. How can I find to the right of it, you guys? 1 minus, okay? Anytime you're doing greater than, you always are going to do 1 minus whatever area they give you, because the table is always telling you left of the point. So if it's greater than, we have to do 1 minus. So 1 minus that number is 0.9625. So about 96% of the data is greater than a z-score. So sometimes we write it out like this. The probability of getting a z-score greater than -1.78 is equal to 96%. Jake, do you have a question? We don't do that yet. We'll get there. We'll use those eventually. Right now, we're only using table A for normal distributions. All right, by the way, this is only used, might as well talk about that, for normal distributions, okay? They have to tell you it's normal, or you have to check that the data is normal, which we will talk about in the future, next couple days, all right? All right, so find the proportions of observations in the standard that are between these two. Okay, so we did left of the point. That you can just look it up, right? If you do right of that z-score, you got to do 1 minus. Now what if I'm doing in between 2 points? So let's draw this. Again, normal distribution always means we've got a mean of 0 and a standard deviation of 1. So -1.25 is about here, and 0.81 is about here, and we're going to shade in between. Yeah, Jake.
So would you find the area left of 0.81 and subtract the area left of 0.125?
Exactly. So if I find the probability of less than 0.81, right, a z-score less than 0.81, that's going to give me all the area to the left of this point, right? Well, all I need to do is subtract out this area that's to the left of -1.25. So we're going to find both z-scores, or areas, and then we're going to subtract them. Okay, so use your table, you guys, and let's find the area for positive 0.81, which is how much area is left of a z-score of 0.81. Anybody got it? What'd you get? 0.791. Okay. I agree with you. Anybody got -1.25? What area is left of that? Jake? 0.1056. Yep, that's what I got. Okay, again, this tells me the entire area left of it. This is left of that, so we subtract them. 0.7910 minus 0.1056 gives me 0.6854. So if we round, about 69% of the data falls in between those z-scores. Okay, what if we want to work backwards? So we had the z-scores and we found the area under the curve, right? What if we are starting with the area under the curve and we want to find the z-score that goes with that? Okay, so 20% of the observations are greater than what value? So let's make a picture here. Okay, 20% are greater than what value? Well, if we look at the area of the curve, we've got 50% right in the middle, okay? So we can just estimate 20% being right about there. Okay, 20% are greater than. We want how much is greater than. So we got to go to our table, table A. And we want to find 0.2. What is the value? We're looking for the z-score that's closest to 0.2. So again, they're giving you areas on that chart. So if everybody looks, try to find where 0.2 is, right? You've got 0.9, 0.46, all kinds of values on here. So 0.2 is on the first page, I believe, the negative page, or is it on the positive page? Actually, you guys, we got to think about this for a second. If 20% is greater, you guys, does that correspond to a negative z-score right here? No, this is a positive z-score, right? So what are we doing wrong? Yeah, we got to do 80% because I need left of it, right? Our table only does left of. So this is 20%. Well, that means we actually need to find 0.8. Unless I was over here, and then 0.2 would work, right? So since I want 20% greater than, somebody find me what z-score you think that is. Zach, what'd you get? Okay. So this corresponds to a z-score of 0.84. Okay. So 20% of the data is greater than a z-score of 0.84. Let's do this with a real problem, all right? So where it corresponds to something. So first of all, draw the graph with the boundary identified, perform the calculations, show your work, and answer the question, okay? So let's try it with a little Tiger Woods problem. So on the driving range, Tiger Woods practices his swing with a particular golf club by hitting many, many balls. Suppose that when Tiger hits his driver, the distance the ball travels follows the normal distribution with a mean of 304 yards and a standard deviation of 8. So as soon as you see that, you can write this down, normal distribution with a mean of 304 and a standard deviation of 8. So what percent of Tiger's drives travel at least 290 yards? So we did these charts last time, but we used the 68, 95, 99.7 rule. So this time it's probably not going to be exactly on one of the standard deviations. Or you could use it, that rule, if it is on one. So we have a mean of 304. We're going to add 8 for the first standard deviation. So I have 312. Add 8, that's 320. Add another 8, that's 328. Subtract 8, that's 296. Subtract another 8, 288. Subtract another 8, 280. So always draw the graph, right? Now what are we trying to find out? The percent of his drives that are at least 290 yards. So 290 is about here. At least 290 is greater than 290. Okay, so we're going to start by standardizing what he got. We have to find the z-score in order to use table A. So my z-score formula is always the data point, 290, minus the mean, 304, divided by the standard deviation. So this gives me a z-score of negative 1.75. So I'm looking for the probability where the z-score is greater than or equal to negative 1.75. Just so you know, you guys, you can have greater than or equal to or greater than in this chart, and it means the same thing. Okay, so we're doing to the right of that point. What does that mean we're going to have to do? You always have to do 1 minus, because again, the chart always gives you left of the curve. So we're going to have to do 1 minus to get right of the curve. So anytime you're doing right of it, make sure you do 1 minus. So let's look up on our chart negative 1.75. Anybody got the area to the left of negative 1.75? 0.0401. That's what I got. So you get 0.9599 when you subtract. And so that rounds to about 96%. And we always have to answer the question, you guys. So you would write the sentence out that about 96% of Tiger's drives travel at least 290 yards. All right, so we did a greater than one. The less than ones are the easy ones. And now we have to do an in-between one. So now we want to know what percent of Tiger's drives travel between 305 and 325. So I'm going to redraw my table. So between 305, that's about right here, and 325, we'll say that's about here. So anytime you're doing in between, right, we're going to find left of this point, which gives us the whole entire thing left of, and we're going to subtract left of the 305 score. So what do we have to do first before we can use table A? Find the z-scores for each one. Okay, so a z-score of, we'll start with 325. So we do 325 minus the mean, which is 304, divided by the standard deviation. Gives me a z-score of 2.63. And we need a z-score for the lower one, so 305, your data point, minus the mean, divided by the standard deviation. Gives me 0.13. Okay, we're finding the probability of a z-score that's less than 2.63 and the probability of a z-score that's less than 0.13, and we're subtracting. Okay, so somebody different, give me 2.63. Someone who hasn't participated yet, make sure you're using your table right. And somebody else, 0.13. All positives. Because all of these are above the means. They're all positive. CC, did you get one? Okay. And Taylor? Nice. Okay. And subtract them, and we get 0.4440. So about 44%. And again, we'd write a sentence of Tigers, golf, drives, fall between 305 and 325 yards. Okay. Jake, do you have a question for me?
Yeah, so if it falls between two, like we rounded, but if it's like 2.625, will you be able to like average between 6.02 and 6.63?
Yeah, you can do that. Yep. Yep. Cool. All right, so I have a, oh wait, we got to work backwards. Forgot. We got to do one where we work backwards in real life. So what distance would the ball have to travel to be at the 80th percentile of Tiger Woods' drive lengths? So again, draw a picture. It always helps to draw a picture. Whoops. Okay, so we have to be at the 80th percentile. So that's over here where we were before. We So our z-score, what area are we going to look up on table A? For this one, we are going to look up 0.8 because it's left of it. All right, so we want to be 80% greater here. So this is left of that. So 0.8, you look for the area and you find the z-score that's closest, okay? It's not perfect, but closest to 0.8 is a z-score of what? 0.84. All right, now that we have the z-score, we're not done. So last time we were done because we just wanted the z that goes with it. For this one, we want to know the distance he has to travel. So we can use this formula. Z is equal to the x minus the mean divided by the standard deviation. Okay, that z-score formula. So if I plug in 0.84 for z, we're trying to find the data point that goes with it. We know our mean is still 304, and our standard deviation is 8. So I'm going to multiply by 8, and then I'm going to add 304 to both sides after I multiply by 8. And we get a data point of 310.72, which I would round up to 311 yards. Okay, so once you find the z-score, when you've got the real-life problem, convert it back to the data point, and that means that to be at the 80th percentile, he has to have a drive of 311 yards. Okay. So I have one worksheet for you guys to do in class.